Okay, so my hopes are that when you're doing these types of problems, guys, that you're thinking about what math is involved before you actually start doing the math. So my thought is, if I look at these two here, that's probably a good pairing of angles because those are equal. So I should be able to say 5x minus 52 is equal to x plus 12, right? And hopefully that's an equation we solve pretty easily. Once we get x, then it really doesn't matter from there where we go in regards to finding y, whether we use maybe those two blue angles to find y, or maybe those two blue angles to find y. Okay? But this equation exists in that form, should be pretty easy to address. If you're a person that says, I looked at these two first, that's okay, because what happens if I go 4y minus x minus 12 plus then x plus 12, what happens to the x's? A negative x and a positive x cancel out. What happens to the positive 12, negative 12? There should be some desks out in the hallway. You might have to go down a little ways to get one, but it should be open for you. But negative 12, positive 12 cancel out, right? It leaves me just 4y equals 180. That should be hopefully something we can answer pretty quickly. Okay? And now do something to address what x is. The thing that happens a lot of times is that people do this. They say, okay, I'm going to look at this angle and that angle. And when we add those together, we get 5x minus 52 plus 4y minus x minus 12 equals 180. And now we get 4x plus 4y minus 64. I'll move that minus 64 over here, gives me 244. I get something like that. Now I can't get rid of x or y, right? Does that make sense? Okay. That happens in this problem if I look at that red angle and that black angle, but there are other equations that you're going to go through in order to address that. That the x is going to pop off the screen and the y is going to pop off the screen. Okay? And my hopes are that we can address a question like number 6. But there are questions later on in this assignment where no matter what relationship I look at, I get something like 4x plus 4y equals 244. And we will talk about how we address those. Is that correct? Okay, that's what we're starting with. So let's do one of those where it's kind of unavoidable in regards to whatever relationship we choose. So if I look at this one, can everybody see? Like, it's nice that they let me zoom in, but then they cut the picture in half. It's stupid. But if we do that, is that okay with everybody to see these angles that we're going to deal with? What could you tell me about maybe those two? Supplementary, right? And this is a case where I think the y's are going to cancel out anyways, right? 5x minus y plus x plus y equals 180. Should give me 6x equals 180, correct? So again, the x's, the way the components for these parts of the problem kind of work together, the y's dissolve themselves, the x comes off the page, I'm able to solve for x. Now I know x is 30. Can I look at that one and say, okay, well, it's now x plus y plus 5y, so it's x plus 6y equals 180. But what was x? X had to be 30, didn't it? Okay. So can I replace that 30 right there and now have a way to solve for y? Okay. So hopefully with these types of questions, again, you're seeing that kind of pop up, okay? Once you found x to be 30, maybe in that relationship, you could have done the same thing. You plug 30 in there and had 30 minus y equals 5y. Solve that equation. Let's see if there's any in here. Okay, so these expressions do not, no matter how I organize them and relate them, the x's and y's do not disappear, right? Okay, we've got some options here. The way I've been working with people, I've seen people kind of, usually when I'm working with you individually, if you come to me with stuff already written down, I'm just going to go with the route that you chose. I'm going to tell you, hey, this is a better route or anything like that, because I think the route that you chose is probably the one that makes the most sense to you, right? So I'm going to try to correct that thinking. But if I look at those two angles, what's the relationship between those two angles? Supplementary, aren't they? Can I take and add those? I'm just going to add them together real quick as x plus 2y plus 19 equals 180. Is that fair? Okay. Now, if I look at maybe these two angles, is it fair to say that they are maybe 4x's plus 1y plus a 19 equals 180? Is that right? All right. So if I'm going to do something like this, guys, I've got two equations, two variables, and neither of those relationships that I use allow the variable to kind of dissolve itself. Okay, so we have to do the algebra to get this here. We have to do the elimination. Okay. When you're doing elimination, and this is something you guys talked about last year, is that you're going to want, I'm going to write an arbitrary equation here. Ax plus by equals some constant c, and then this will be dx plus ey equals some arbitrary constant f. Okay, that's kind of what we want. We want our x's on top of each other. So a and d are just coefficients. I want our y's lined up on top of each other. So b and e are just coefficients. And I want my constants. I want my constants to be lined up on the other side of the equation. There are other ways of doing it, but it makes more sense to have those constants over there on the right-hand side by themselves. Okay? They're called constants because there's no variable part to it, right? Variable means to change. So that 180 is a constant. 19 is a constant. Those numbers are not changing, right? The x and the 2y, those are variable terms. They change based on what x and y's, or what the x and y values are. So we want to kind of develop this kind of structure. So I'm going to move this 19 over there through subtraction. So it should give me what, 161? Okay. Move this one over as well. So it gives me 161. Okay. Now, a lot of times you won't get the same 161 on both sides. But we're now going to try to add straight down. Well, if I add straight down, my x's are going to go to 5x, my y's are going to go to 3y, right? Gives me a new equation that's not going to help me at all because it still has x's and y's in it. What we talked about in Algebra 1, that we can go through and we can multiply these equations by anything we want to. Okay? I think it'd be nice to look at that y, which is a 1y. What if that was a -2? Would that cancel with that 2? So we'll multiply everything that's bottom equation by a -2. Okay, so multiply everything by -2, and that's going to turn the equation into -8x minus 2y minus, okay, so 160 would be 320, right? So 322. Is that right, everybody? Now I'm going to, because that top equation did not change at all, right? So now I'm going to add those two together. All right? So if I add those two together, how many x's do I get? -7 x's, right? When I add these two together, it's going to be -161, right? Okay. Divide by -7, divide by -7. Okay, 7 goes into 16 twice. It'll leave me a 2 and a 1 left over, so 21, so it goes into 21 3 times. So get x to be 23. Is that all right? So if x is 23, I should be able to take that x back into any equation that I have and solve for y. It doesn't matter what equation, as long as it's an equation that you use throughout the problem. Okay? If you guys agree that we use this equation throughout the problem somewhere. All right, so let's plug it in there. I think that was the easier one because I can multiply 23 by 1 a little bit easier than multiplying 23 by 4 here, right? Okay. So we'll go 23 plus 2y is equal to 161. So 2y, 161 minus 20 would be 141, right? We'll subtract 3 more would be 138. And now I'll divide that by 2. So it goes in, what, 69 times? I got my y, and now I've got my x. All right? Now, is that the only way of doing it? Absolutely. There's an infinite number of ways of doing this, guys, because if we go all the way back to what we said at the beginning, that we had 1x plus 2y equals 161, and this is the issue that we have a lot of times, is I can multiply this one by -4 and top one by -4. Will I get those two canceled? Can I multiply the top one by -12 and the bottom one by +3? Will that get those two to cancel? That makes sense to everybody? So there are, because of the multiplication idea, there are an endless number of ways that I can multiply these two equations so that some of my coefficients match up. Now, are there easier ways than others? Yes. Okay. I think the most logical way is either to multiply the bottom one by a -2 to get your y's to cancel out, or to multiply the top one by a -4 to get your x's to cancel out, right? Okay. If you struggle trying to decide what do I need to make my x's or what do I need to make my y's, take the coefficients that are with your x's and multiply them together. If they give you 4, then you need to turn them both into 4. Multiply these together gives you 2. You need to turn both your y's into 2. Does that make sense? Okay. If for some reason, let's say this coefficient out here was a 3x. Okay. And multiply those together, I get 12, right? That means I would have to change the top equation so that gives me a positive 12x, and the bottom one so it gives me a negative 12x. Okay. So just multiplying those will tell me what I can make them or what I should make them. Now, hopefully you guys agree that that's maybe some work there, right? That's some effort. This is why I think it's beneficial for us to recognize alternate routes. Regardless of how you said, maybe you're a person that said 4x plus y equals 161, or you said, was it x plus 2y equals 161. Well, either one of those equations that you develop, what's nice is there's another relationship here, isn't there? Doesn't y equal 3x? So what's that mean? Can I come up here where I see y and kick it out and replace it with 3x? Does that give me 7x equals 161? Can that solve for 23 right away? See how much more efficient that is to look at that additional equation? And you could have plugged in here as well. I could have said, okay, it's 2 times 3x. Well, 2 times 3x is 6x, plus 1x is 7x. I get the same equation, 7x equals 161. What I like to do, if there's multiple equations, okay, so I see if there's 3 relationships up there. There's 2 linear pairs and 1 set of vertical angles. I'll write down all 3 equations, okay? And writing down all 3 equations might allow you to see if there's an easier, quicker route. I'd rather take the 5 seconds to write an extra equation if it's going to save me 3-4 minutes in the work. Okay. Not always, writing that third equation might not always produce something simple. All right, but at least opens your eyes to its existence if there is an alternative route. So some of these, I think, at the end, for instance, this one, I don't think there's going to be a real simple equation here. We could say, 5y plus 4x, 5y plus that 4x should equal 180, right? Okay. We've got the relationship that those two should be supplementary. So we got what? Another 5x plus 1y plus 102 equals 180. Okay, now when I write it, because I know the system, I know the process, I'm going to get that 102 to the other side. So can I make that other side 78 instead? Something to do, okay? Get your constants on one side. And now the next one would be this relationship. 5y equals x plus y plus 102. So now, looking at that, if I wanted to rewrite that like the other ones, it's going to turn into subtracting my y from both sides, so 4y, subtract my x from both sides, And I leave the 102 on the right-hand side, so that would be the vertical angles relationship. And now if I look at those, I can choose, guys, I can choose, because they're all three equations that have the same two variables. I only need two of them to work with. Does that make sense? Yes. Choose any two that you want. Choose two that you might think work well together. And I don't know if there's going to be a blue one as a group, or choose the red one and a blue one as a group. Okay? But you'll have to go through and try to eliminate your x's, eliminate your y's. Okay? Some of you might see this. Some of you might say, oh, right here, I can take that one and rewrite it as y equals 78 minus 5x. Did you guys agree with that? Y is equal to? Can I then take that y, and I'm just going to put it in this bottom one, but can I take that y and say 4 times y, which is 78 minus 5x, minus x equals 102? Did that get rid of my y's? All right, so last year I think you guys learned that when you're dealing with system equation and your x's or your y's, if there's a coefficient of 1, the quickest route is probably substitution. That's what that is right there. Okay. If they're not 1, or you can't easily make them 1, then you're probably going to go through the elimination route. Does that help a little bit? Okay. The questions over these. When we approach questions like this, and this is the good thing, but it's also the bad thing about the class, is that there's a lot of relationships in this picture that are true. Some of them you need maybe multiple relationships to really develop any algebra. It allows you to kind of press through the problem. But there are varying techniques that we can use to solve this problem. And we'll try to talk about that as we pass through it, but my argument to you guys is just because of the way that I do it in class does not mean that's the only kind of end-all, be-all way. And the more we understand about our algebra, maybe the better we can kind of justify the different ways. Okay? If I look at that angle right there, and that angle right there, what is the argument? What's the relationship that we're going to say about those two angles? Okay, so they're supplementary. So we're going to say 4x plus x plus y plus 36 equals 180, right? Okay. Now, as we look at that equation and maybe start simplifying it, we'll talk about why we have to do this later, but I'm going to make that 5x plus y. I'm going to move this 36 to the other side, so it gives me 144. Okay, I just subtracted that 36 from both sides, right? So that is the relationship that we have right there. Now, what is problematic about that? I have two variables, right? So then somebody will say, well, if I got two variables, then I need another equation that has the exact same two variables. If I look at those two angles, let's get that little box out of there. Look at those two angles, well, can we make the same argument that x plus y plus y plus 36 equals 180? Is that okay to say? That's adding x plus y plus 36 plus that y. That should be okay, correct? Well, that's x plus 2y equals 144. I'm going to combine like terms and, again, move that 36 over. Okay? Is that all right with everybody? Now, the reason we do that is because last year in Algebra 1, and this is the issue that you guys are going to see and deal with on a regular basis all through mathematics. Okay, it might be the first time we're seeing it now, first time we've experienced this, kind of to the degree that we're experiencing it, is that what you learned in year 1, once you pass through that, it is understood that, or it's assumed, I guess, that you understand that and can use that whenever the situation might arise. So this is a situation that we need to take this information and create what we call a system equation to solve this problem. Okay, now bear with me. I'm trying to make sure that my audio is on here. It seems that everything's freezing. All right, whatever. That's the problem. Okay, give me 1 second. Okay, there we go. All right, so what we need to do then is we need to take these two equations and we're going to set them on top of each other. Okay, kind of like that. All right, now, last year you learned this approach. All right, so where you take your two equations. Now the capital A, B, D, and E, they're just coefficients. The E numbers they want to be. So for us, they're 5, 1, 1, and 2. The C and the S, those are constants. So for us, they're 144. Okay, both of them. And we stack them to your X's on top of each other, or your Y's on top of one another, right? And our constants are on top of one another. There are other ways of doing it. Okay, we could actually, and I'm not going to spend a lot of time using this kind of notation, but we could actually put like the plus C plus F on this side and then 0 on that side. That's one strategy that we may use at some point. But if we learn that we just put our constants on the other side, that's the best thing to do. So that's why I kind of, as we were working through these equations, I moved that 36 over because I knew I wanted to get to this. And the reason we want to get to this is because we're going to add these things straight down. And the hope is that either the X's disappear or the Y's disappear. And the only way that can happen is if they are additive inverses, meaning that they're opposite coefficients, right? Do I have any opposite coefficients here? No. So last year I think you learned that you can go ahead and you can multiply these things by anything you want to. So what variable do you want to cancel out? Just give me that statement first. Y is fine. When I ask you that question, there is absolutely no wrong answer to that. If you're a person that always wants X's to cancel out, then you always cancel X's. You want Y's always cancel out, always cancel Y. If you want to be thoughtful of it and say, okay, Y's make more sense here because I can double everything pretty easily, then make the argument off of that idea. I'm going to double all of these and multiply by a negative at the same time so that I do get opposites. So it's going to take that top equation and change it to negative 10x minus 2y equals negative 288. The bottom one's going to be x plus 2y equals 144. Okay, and then change the bottom one, right? Now if I add straight down, how many x's do I get? Negative 9x's, right? What happens to my y's? Cancel out. And I get negative 144 for these constants added together. Is that an equation now that you can solve pretty easily? Okay, I believe that gives me 16. Okay. Does that make sense to everybody? So now I've got x. All I have to do is go back in and do some work, and I just substitute in any of the equations that I had throughout the problem. It doesn't matter which one, as long as it's a true equation. I'm going to plug back into this one right here. Because I can put 16 in there is a little bit easier than taking 5 times 16 right there. So we're going to go 16 plus 2y equals 144. Subtract 16 from both sides. So looks like it'll be 128. All right. So the y is going to be what? 54. So those are my values for those two variables. Okay. And that is the way we can approach that question. Let's write it this way. That's one way we can approach this question. Okay. Well, you guys agree that's a lot of work. Okay. Did anybody do this? Did anybody say, okay, yeah, those two equations are indeed true, and we can use those. There's nothing wrong with using those two. But is there a third equation that says y equals 4x? Do you agree with that? Can I now take that y and use either one of these equations or their kind of initial versions and plug y, or sorry, replace y and plug in 4x into its spot? So we'll take this top one. Well, I have 5x plus y, but y is now 4x equals 144. Does that get me to that statement right there real quick? X 16 right there. If x is 16, can I come back up there and plug that in? And it says y equals 4 times 16. Does that make sense to everybody? I saw a lot of people, and there's nothing wrong with this. I saw a lot of people trying to press through the system of the equation. And that's doing it that route. It's still a system equation. System equation is a fancy word for 2 equations or 2 variables. Okay? Or 3 equations, 3 variables, or 4 equations, 4 variables, whatever. It's still a system. But a lot of people are trying to press through using elimination, which is fine. It's absolutely fine. But it might take you 5-6 minutes, right? Where if I write down that third equation, it might take me 10 seconds to write down y equals 4x, right? And then if I have that, thinking about the versions of math that that are available to use might save me 3-4 minutes in the problem. That kind of makes sense to everybody? That's the downfall of the course, I think. That's downfall of really anything that incorporates algebra. The more algebra you understand, the more geometry you understand, it opens the door to alternative techniques. Okay? And if you're a person that's not learning all the additional things that we've talked about, you might not be privy to one of these additional techniques that makes things a little bit simpler, a little bit easier. And if I use that one in class, you might be like, well, how can you do that? It's because of the stuff that we've learned previous. Does that make sense to everybody? That's kind of hard, I think, to think about. But the more we learn, the more we pick up on, we open up shortcuts. Okay? I think that's a good question to talk about and deal with. Is that all right? So, and that's the case, guys. You learned 2 techniques last year: substitution, elimination. You can use either one anytime that you want to. Okay. However, the benefit is that if I know both of them, I should be able to use them efficiently. I can be able to interchange them as I see fit to quicken the pace. There are other things you guys can do. Okay, now, and this is not in place of the algebra, but it is something that might be beneficial for you. Okay, we had some equations, right? We had now GeoGebra or Desmos is probably the best place to type this stuff into. I would not use my TIE 3 or 4. You got to do some extra work there. But if I go 4x equals y, it'll graph that line here in a moment. If I graph 4x plus x plus y plus 36 equals 180, it will graph that line. And you see that it did that simplification that we came up with earlier, right? Give me the 5x plus y equals 144. If I go x plus y plus 36 plus y equals 180, it gives me that equation. Okay. Now what we're doing here, algebraically, what we did by hand, guys, is that we took all 3 of those lines and try to figure out where they equal each other. And it's at that point right there, correct? If I look at that point, the intersection of either of those 2 of those 3 lines, do we get x to be 16 and y to be 64? And that's what we're seeing. That's what we're doing by hand. We're trying to find that point of intersection of those lines. Okay. Now, what's the problem is if I use my TIA 384 to do this, your TIA 384, you have to convert both these into y equals and then type them in that way. Okay, which that might be a tough thing for someone to do. Okay. Does that make sense? You can use your technology to help you guys, or help at least get your answers. Right? Like I said, don't use that in lieu of doing the work, okay, or in place of doing the work. Do the work by hand. Then use, before you type into Math Excel, use GeoGebra to verify that you have the right answer. Does that make sense? Okay. Or what I like to do is I like to know that, hey, GeoGebra is going to give me the answer. Desmos is going to give me the answer. Figure that out first. And then go through the written work and see if I can produce or replicate that answer. Isn't it a lot easier to take a test knowing what the answers are before you do anything? You should be able to kind of do that in a lot of things that we do throughout the year. All right, so are these here, like question 10, 11, 12, where you might have in questions like 1 through 9 some examples where you didn't have to use a traditional system of equations because a relationship that you recognize was able to solve just for X or just for Y. And then you can use that throughout the other part of the problem. Okay? Meaning like right here in question 9, 9 doesn't do it, this one doesn't do it. Okay, this one here. There's a link here between these two angles that automatically dissolves the X. I'm left with 5y equals 180, right? That allows me to solve for y right away, and I can then use y maybe in this relationship here. Okay? That's still a system. You're still using two equations to solve the problem. But it's a little simpler. Let's get to one like this. Okay? And here's my thought, guys, is that there are more than one way, or there is more than one way of doing this problem. Okay? I want to show you maybe a couple of those ways or a couple of those techniques. But at the same time, hopefully you start to open your eyes to the benefit of learning more algebra, learning more geometry, so that you can save yourselves a little bit of time. So if I do this problem, let's see here. Let me already tell geometry being pain about. We'll close this out. All right, so we get this picture. Would you guys agree that there's a link between those two angles? Okay. Now I'm going to do the algebra kind of in my head here, but would you have two y's there? Would you have a plus x and a plus 18? What are you going to set that stuff equal to? 180. Okay. Would you make the argument that you have these two angles being supplementary as well? So you have 5 x's, 1 y, a positive 18, and 180, right? Okay. Now, just because I know the overall structure of what a system looks like, I'm going to use a certain approach. Because remember last year, I want you to use just arbitrary letters here, meaning that I don't know what they are, but they are. Standing for coefficient. Bless you. You guys remember setting your x's on top of each other, setting your y's on top of each other, setting your constants on top of each other, and trying to add straight now and get either my x's to disappear or my y's to disappear? All right. This is the structure that you want to do that with. Okay. Now what I've got here is fine, but it doesn't match up real well to this, and it's not really safe to leave this the way it is, because sometimes people are going to know what to do with that constant and that constant, because I got constants over here and over here as well. So the best thing to do is to rewrite these with those 18s moved to the other side. So if I do that, I'm going to have, what, 2y plus x equals 162, and I will have y plus 5x equaling 162 as well, correct? Now, traditionally, they won't always be both 162. Yeah, it's just what happens in this one. All right, so my hope is I'm going to add straight down. Some of my variables cancel out. Will they cancel here? No. So if they don't cancel, then you got to make a decision. And what's nice about this decision that you're going to make, there's not a wrong answer to it. Okay? I ask you what variable you want to cancel. You choose one. Which one you want to cancel? Okay, y is a good one to choose. But if you would have said x, you're absolutely fine. The reason I would not choose x is because I'll have to multiply everything by 5 if I chose x. And I can't do 162 times 5. Okay? Does that make sense? Choosing y, logical choose y, because I can do 162 times 2. I can do 5 times 2, right? So there's not a wrong answer, but there's a best answer. And in this case, canceling y's would make sense. So what do I need to do? If I'm going to cancel y's, what do I need to multiply this bottom equation by? -2. Okay? So that's going to produce then for me, and I'll write it over here, because I can't erase that arrow for some reason. The red one isn't going to change. Let's say 2y plus x equals 162. But the blue one becomes negative 2y minus 10x equals negative, okay, was that 384? Is that okay? Okay. Is that right? Huh? 324. All right, so now, can I add straight up? Now my y is going to 0y, right? Well, 0 times y is just 0, so it dissolves that variable, it eliminates that variable. And now I have negative 9x's here, and it's going to be negative 162, right? Okay. 9 goes into 16 to 1, leaves me 7, so I have 72. It's going 18 times, right? 162 divided by 9 is 18. So now I know what x is. Does that make sense, everybody? Okay. So now that I know what x is, the practice last year was to take that x and plug it back into any one of the equations that you use throughout the problem. I've got a lot of options. A lot of them are the same, but it doesn't matter where I plug it back in. Okay, I'm going to get the right y value back, as long as the equation I used was true. Now, here's where it makes sense to kind of think logically. If I've got x, doesn't it maybe make most sense to plug back into that one right there? It's the most simplest version that deals with x, right? So I'm going to have 2y plus 18 equals 162. Subtract 18 from both sides. I have 2y is equal to, what, 144? Okay. And then what's y going to be? 72. Okay. And now I've got those two solutions. That's using the system. And if you're struggling with that, again, because we're going to see these throughout the entire year, guys. The way the textbook is structured, and really every geometry course you come across is this way, is that early on, first couple chapters, you deal with one variable equation, multi-step equation. You start getting better at those. You've revisited that algebra 1. Now they say, okay, now we're going to learn new geometry, but we're going to do it with systems. So we go back to the system of equations aspect of algebra, and we brush up on that. We get better and more skilled at that. And once we get real skilled at that for 2 or 3 chapters, then they say, okay, we're going to go back to factoring. Go back to x squared plus 4x plus 4, that kind of stuff. Okay? And we brush up on that and get better at that. And then once we're done with that, we say, okay, let's go back to maybe radical equations. Okay? Things that have square roots in them and stuff like that. So it's progressive that throughout the course, we're going to go back to target different areas of Algebra 1. All right? Which I think is beneficial to you, because guess what happens in Algebra 2? You go in further depth with this stuff. Okay? In Algebra 2, you'll talk about systems again. All right? In college algebra, we talk about systems again. So we use this stuff over and over and over again. And hopefully by the time we get to those in Algebra 2 and college algebra, it's just second nature and how to address it. Now, here's my argument. Is that the best way to do this problem? Is that the only way to do this problem? I don't think so. Okay? And that's what kind of stinks for some of us, is that there might be alternative versions. This is where learning more math, learning more concepts can benefit us. What's the relationship between those two things? Y equals 4x, right? Okay. Can I go back to, I think we had an equation, I erased it for some reason. We had 5x plus y equals 162. Is that correct? We had one of those equations like that? Now if I know y is equal to 4x, it's still a system. If I use that equation and that equation, the definition of a system is an equation that has the same, or sorry, a set of equations that have the same exact variance. Okay? Can I come up here and say that this y is now going to get substituted as 4x? Gives you 162. So I now have 9x equals 162. Where through the other approach, we had negative 9x equals negative 162. And it took us forever to get to that. But now 9x equals 162. It still gives me the same x to be 18, right? What's nice about that? If x is 18, what's 18 times 4? 72. The same y value that we got, right? So you see how understanding different approaches, understanding different relationships geometrically might open the door to a shortcut? or maybe not a shortcut, but maybe the same procedure that I'm just able to go through a little bit quicker just because of the way the parts kind of relate to one another. Does that make sense? Substitution elimination. If you remember last year, maybe a test, they just took it, Algebra 1. Okay, it might have been Algebra 2 they just took it. They'll tell you, do this question using elimination. The next one says, do this question using substitution. And the third one says, use any technique you want to. Because no matter which one you come across, no matter what system you come across, you can use any technique you want to. If you're a person that says, I'm always going to use elimination, that's fine. If you're a person that says, I'm always going to use substitution, that's fine. However, if you're one of those people, you're always going to at some point get in a predicament. And if I was a person that only did elimination in this question, do I waste time? Yes. If I understand my other alternative routes, maybe I get the question done and I save 3 or 4 minutes. Okay? What's the benefit of that? Time. Okay? Saving time. You get to an ACT, 60 questions, 60 minutes. Don't want to use that route on an ACT question if there's a simpler, quicker route. All right, everybody? All right, so hopefully that helps addressing